So for Chapter 9, Section 7, we are going to be talking about another way to solve these quadratics, and it is using a specific formula called the quadratic formula. The really nice thing about the quadratic formula is that this can be used to help you factor or solve any type of quadratic equation that you might see. So if factoring doesn't work, if graphing isn't the greatest method, if completing the square doesn't seem to be working, quadratic formula will work no matter what your problem looks like or how it started. So the quadratic formula is right here. It's a little bit bigger of a formula, and you are going to want to be very familiar with that. So find a way to memorize that, to be able to keep that in your pocket so that you can pull it out when you need it when you're trying to solve these quadratics. So to solve for your x values, what you're going to do is take the opposite of your b term, plus or minus the square root of b squared minus 4ac, and it's going to be all over 2a. Where the a, the b, and the c come from is from your quadratic equation. Remember, we've been dealing with things that are in this form all chapter long. And so the a, the b, and the c, those come from those numbers that are sitting in your equation. So you're going to pull those numbers, plug it into your formula, and then evaluate. Now, the piece underneath the square root does have a specific name. It's called the discriminant. And that piece, the b squared minus 4ac, it's used to help you understand what type of answers you're going to get when you're using the quadratic formula. So if you evaluate just that portion underneath the square root there and it's greater than 0, you're going to have two real roots. So you're going to have two answers. They're going to be like numbers, like whole numbers, or maybe fractions, maybe decimals, but they're going to be able to be found. And they're going to be, fairly normal numbers. Now, if it's less than 0, then you're talking about imaginary roots, which we haven't gotten into a whole lot, just because you will see more of that in Algebra 2 in a couple years when you guys move on. The other option is if that piece underneath the square root equals 0, that means that you're only going to have one real root. So when you look at the graph, the vertex is sitting on the x-axis, like we've seen before when we were graphing these. In order to use your quadratic formula, here's your steps that you want to follow. You want to set your equation equal to 0, identify the a, the b, and the c, be able to kind of find that discriminant first so that you understand what type of roots you're going to have, and then plug in your a, b, c into your equation, evaluate the quadratic formula to be able to find your two solutions. So I have this example here for us, where we have x squared plus 9x minus 11 equals 0. So remember, your a is always in front of the x squared term, so that's where they're getting that 1 from, because it's 1x squared. B is in front of your x, so that's the c, or the 9. And c is always the number at the very end, which would be that negative 11. So a is 1, b is 9, c is negative 11. Now what they did here is they plugged it into that quadratic formula that I highlighted up above. So they're putting in the 9s for the b's, the 1s for a's, and the negative 11s for your c's. Now when you're evaluating the quadratic formula, I would take your time. It's not a race to see who can get done the fastest. Piece it apart, kind of focus on a specific area of your formula first and kind of work there. I usually start with like underneath the square root sign and then work my way to dealing with the numbers that are sitting out front. So you can see what I did here is I did that 9 squared underneath the square root here, and that's how I got 81. And then I took this negative 4 times 1 times negative 11, so I evaluated this piece next, and that's how I got that 44. And it's positive because I had a negative times a negative underneath that square root. The negative 9 is still sitting out front, and on the bottom here, that 2 times 1 is just a 2. So all I've really done is simplify just a little bit at a time here. Then what I did is I added 81 and 44, so that's how I got this 125 underneath my square root sign. And if I try to square root 125, you're going to get a decimal, which I'm not entirely sure what it is exactly. It's probably 11 point something. But so this would tell me that I'm going to have two irrational roots, and all that means is that they're going to be kind of messy numbers. So you're going to have those decimals that have no pattern to them, they don't repeat, they never end. So if I needed to find the kind of rough estimate of an answer here, I would evaluate this by square rooting that 125 and then splitting it apart. So I would take negative 9 plus that and divide by 2, and do negative 9 minus that and divide by 2. And that would get me my two answers that I was looking for. So go ahead and try to do this practice problem, and when you're ready to see what the answer or answers should have been, go ahead and keep watching. So your A for this one is a 1, your B is 10, your C is 25. So we do opposite of B, so we're going to take negative 10 plus or minus. Under the square root we have 10 squared minus 4 times A, which is 1, times C, which is 25. And this is all over 2 times A, 2 times 1. I'm going to isolate just kind of underneath the square root for right now. So I have negative 10 plus or minus. 10 squared would be 100. And then negative 4 times 1 times 25 would be negative 100. And that's all over a 2. Now with the square root here, 100 minus 100 is 0. So this is going to be gone because the square root of 0 is 0. So I'm left with that negative 10 over a 2, which is negative 5. And remember when we talked about the discriminant at the start of this lesson, I had said that if the piece underneath the square root was a 0, that you were only going to get one answer. So it matches kind of what I had talked about earlier. Let's take a look at this example together. So they don't have this one set equal to 0 because you can see how they have it says equals negative 15. So before we start grabbing our A and our B and our C, you're going to want to move this negative 15 over here to the other side. So we're going to do that by adding 15 over to the left-hand side. So my new quadratic is going to say 10x squared minus 31x plus 15 equals 0. Now your A is the 10, your B is that negative 31, and your C is the 15. So when I go to plug this into my quadratic formula, it's going to be the opposite, so negative of your B, which is negative 31. So all that's going to happen here is this is going to become positive. Plus or minus the square root, we have B squared first, so negative 31 squared, minus 4 times A, which is 10, times C, which is 15. And this is all over 2 times A, so 2 times 10. So I'm going to change this negative negative to positive 31, plus or minus. Underneath my square root here, the negative 31 squared is going to be 961. And then you have this negative 4 times 10 times 15, which is going to be negative 600. And that's all over 20. So I have 31 plus or minus. 961 minus 600 is going to leave you with 361. And that's all over 20 still. Now if you have a calculator, you're probably going to want to square root 361 to see if it comes out as a whole number or a decimal. For this one, it's going to come out to be 19. So we have 31 plus or minus 19. And the square root sign is gone now because we already did the square root of the 361 to get to our 19. And this is all over 20. So now what I do at this point is I kind of split this into two separate parts because you're going to do the 31 plus the 19 and divide that by 20. And you're going to do 31 minus the 19 and divide that by 20. So if we do this, we may not get nice whole numbers, but if you get fractions, you can always try to reduce them. So for the 31 plus the 19, that's going to be 50. So you have 50 over 20, which you could take a 10 out of both. So that reduces to 5 over 2. For this other one, you're going to do 31 minus 19 and put that over 20, and that reduces to 3 over 5. So we've got one final practice problem here. Similar to that last one, you're going to want to make sure that you set it equal to 0 first. So go ahead and try to do this one and then keep watching the video to see how it should have turned out. So start by adding 18 over here to the left hand side. So we have 5x squared plus 21x plus 18 equals 0. Your A is the 5, your B is the 21, your C is the 18. So going into my equation, it should have said this: negative 21 plus or minus the square root of 21 squared minus 4 times 5 times 18 all over 2 times 5. Then I focus on my square root piece. 21 squared is 441, and then it's minus 360 when you take negative 4 times 5 times 18. This is all over a 10. So I have negative 21 plus or minus the square root. When you subtract 441 and 360, that leaves us with an 81 all over 10. The square root of 81 is 9. And now I'm going to split this into two separate problems. So negative 21 plus 9 over 10 and negative 21 minus 9 over 10. So for this first one, it should have reduced to a negative 6 over 5. And for the second one, it should reduce to a negative 3.